Welcome to Engineering Graphics. So today's topic is Introduction to Curves. This is the first unit, second chapter. So Introduction to Curves. So in that first one is cycloidal curve, epicycloid curve, hypocycloid curve. Before going to direct problem, we have to discuss some introduction part. So first of all, cycloidal curve. So cycloidal curve. Cycloidal curve is nothing but a cycloidal curve is a curve generated by a point P, curve generated by point a P on a circumference of a circle which moves along a straight line, without slipping. It travels one revolution is called a cycloidal curve. Is nothing but cycloidal curve. A cycloidal curve generated by a point P on a circumference without slipping. It travels one revolution. So this is called cycloidal curve. Then we got some points. So it is traveling second step, third step, fourth step, fifth. Again have to reach for one revolution. Again have to P point. Then you got some cycloidal curve. That is the cycloidal curve. And you have to remember that if you are drawing a cycloidal problem, so you have to consider the straight line distance. The formula is pi d. Pi is nothing but 22/7 and d is nothing but rolling circle diameter, which is given in the question. Rolling circle diameter. This is the cycloidal curve. Okay, so P is on a point on the circumference circle which moves along a straight line without slipping. It travels one revolution is called the cycloidal curve. And the P and Q point we have to fix the straight line and the rolling circle, and another name is we called as generating circle. And consider pi d is nothing but you have to calculate the distance of the straight line, that is pi d 22/7. D is nothing but rolling circle diameter or generating circle diameter, which is given into the your question. And next is directing circle. Yes, next we have to consider hypocycloid. So epicycloid. Next, second one is epicycloid. An epicycloid is a curve generated point P on the circumference of a circle, that is rolling circle, which rolls outside the circle. That is nothing but outside the circle. It is epicycloid. Epicycloid is nothing but circumference of a circle. The point P is rolling circle on the circle. It rolls one revolution. Then you got a theta value here. So theta formula 360 into small d by capital D, which is given into the small d means rolling circle diameter, and capital D means directing circle diameter. And the rolling on the circle which rolls without slipping, it travels one revolution. That is nothing but this is the circle on the circle, that is nothing but rolling circle. It revolves it is revolution for one revolution, complete one revolution without slipping. It travels one revolution. Then you got a theta value. Theta is nothing but small d by capital D. Small d is nothing but given into the equation. Rolling circle, capital D is directing circle. And next one is we have to done the cycloidal and epicycloid. And next coming into the hypocycloid. So hypocycloid is nothing but the curve generated by a point P on the circumference of a circle which rolls inside a circle. The circle inside a circle of circumference of a point P, circumference of a point P, the circle inside a circle with the circumference of a circle, the point P which rolls for one revolution without slipping and inside the circle, that is called hypocycloid. Then you got a theta value here also, so we have to consider. So this is the directing circle, this is the rolling circle, and rolling circle another name is generating circle, generating circle. Same formula, theta, we have to calculate theta value means 360 into small d by capital D. This is the formula, and small d is nothing but rolling circle and capital D is nothing but directing circle. This is the three of the curves: cycloid, epicycloid and hypocycloid introduction part. This is the cycloid introduction